Spotty gotta do?
In lesson 4.4, we're going to look at parallel and perpendicular lines. Okay, you may already know what those words mean, but if not, we're just going to take a look. So first we have some equations here, and let's go ahead and graph these lines. So I have 1/2 x minus 3. So I know my y-intercept is negative 3. There's where my first point is, and then I can go use my slope. So up 1 over 2. Up 1 over 2, and then I'm going to draw a straight line between all of those points. Then we have the line 1/2 x plus 2. So this time my y-intercept is at positive 2. And then I can go up 1 over 2. Up 1 over 2 and connect the dots. And when I do that, I get two lines here. Now, these lines have the same slope. So they're going to continue forever in this direction. But they are never, ever, anywhere in the entire universe going to cross each other because they're going to keep going up and over the same amount. They're both going up 1 over 2, so they're never going to cross each other. So they are what we call parallel lines. All right, they're parallel, they run the same plane, they're never going to touch each other. So let's graph these lines over here. All right, I have 1/2 x plus 2 again, so this is that same line. So plus 2 and then up 1 over 2, up 1 over 2, draw a straight line. And this time the second line is negative 2x minus 1. So I go to minus 1, and then the slope is negative 2. So remember, if it's a whole number, we put it over 1. So down to right 1, down to right 1, and draw my straight line. Alright, obviously these are not like the lines over here. They cross. We can see where they cross. And it might be a little bit hard to tell on here, but where they cross each other, the angle formed there is a 90-degree angle. It's a right angle. Alright, so that makes these two lines perpendicular lines. Alright, so they cross, and not only do they cross, but they cross at a right angle that makes them perpendicular. So let's look at some characteristics of parallel and perpendicular. So parallel lines, they never cross each other. They have the same slope, and if we look back at our example, a different y-intercept. So they have the same slope, the 1/2, but their y-intercept is different, because if they had the same y-intercept, then they'd be the same line. So different y-intercept, same slope. So I want you to come up with an example. Just write two equations for two lines that would be parallel. They have to have the same slope, but a different y-intercept. So pause here and come up with an example. Then we're going to look at perpendicular lines. They form a 90-degree angle, and their slopes are what we call negative reciprocal. So what does that mean? Well, reciprocal means I'm going to basically flip the fraction over. So in this case it was a over b, so now I'm b over a, and make it negative. So if we were talking about, let's say, 2/3, the negative reciprocal of 2/3 would be to flip it over, so it becomes 3 over 2, and make it negative. Okay, where you might have trouble with negative reciprocals is if it's a whole number. So if I have a slope of 2, all right, we're like, how do I flip 2 over? Well, remember, it's really 2 over 1. So the negative reciprocal of 2 is negative 1/2. All right, remember there's a 1 on the bottom. So same thing, pause here, write an equation of two perpendicular lines. So just remember the slopes have to be negative reciprocals of each other. Alright, then we're going to go through some examples. So we have to decide whether they are parallel, perpendicular, or neither. To do that, we need them in slope-intercept form because that's how we can see the slope and the y-intercept to decide parallel, perpendicular. Okay, so for this one, y equals 4x plus 3, that's already done. The red one, though, I need to get into slope-intercept form, so I need to get y by itself. So I'm going to subtract 4x from both sides, so now I have y equals negative 4x plus 3. I don't need to divide because there's only a 1 in front of the y, and that's fine. So my two equations are y equals 4x plus 3 and y equals negative 4x plus 3. So they're not parallel because they have different slopes, and they're not perpendicular because negative 4 is not the negative reciprocal of 4. All right, that would have to be negative 1/4. So these are neither. Alright, here let's look at these. So same thing, the first one is in slope-intercept form already. I have y equals negative 2x. By the way, what would be the y-intercept of this line? If there's nothing there, it would be plus 0. So this one has a y-intercept of 0. Now let's get the red in slope-intercept form, so I'm going to subtract 2x, y equals negative 2x plus 3. So we have negative 2x plus 0 and negative 2x plus 3. They have the same slope, but a different y-intercept, so they are parallel. Alright, now neither of these are in slope-intercept form, so we got to transform both of them, but that's okay because we know how to do that. So for the first one, 3x plus 5y equals 10. I'm going to subtract 3x from both sides. So 5y equals negative 3x plus 10, and then I'm going to divide everything by 5. So y is equal to negative 3/5 x, because that's simplified, and then 10 divided by 5 is 2. So there's the first line. Then let me get my red pen. Now we're going to do this one. I'm going to do it over here so I have room. 5x minus 3y equals negative 6 minus 5x minus 5x. Negative 3y equals negative 5x minus 6. Divide everything by negative 3. Alright, so y equals negative 5 divided by negative 3 is positive 5/3 x. Negative 6 divided by negative 3 is positive 2. So here's my two lines, negative 3/5 x plus 2 and 5/3 x plus 2. Well, 5/3 and negative 3/5 would be negative reciprocals. If I flip 5/3 over, or 3/5 over, it becomes 5/3, and instead of negative, it's going to be positive, so these are perpendicular. Alright, you have on that page 3 more examples. There they are. So I want you to do these and then bring them into class, and we'll go over them in class. So you got to put them in slope-intercept form and then decide whether they are parallel, perpendicular, or neither.